Hello and welcome everyone, and thank you for joining one more coffee break with us today. As you can see today, we're doing things a little bit different, as you can see around me. So I am on a pipeline dig site today, and I wanted to show you a few things. So first of all, I will review the scan plan that we have done on this pipeline dig that is just behind me. So if you can share my screen at this point, on the screen, what you see here is the Spyne array probe. So this is an eddy current array probe that we are using with the Ready instrument. This probe, we've been talking about it a lot. It is being used to inspect pipelines, so the external surface of pipelines as a replacement for magnetic particles. So here is a picture I just took of the pipeline joint that we inspected this morning with the Spyne. It is 40 feet long and has an outside diameter of 42 inches. Because of this very large length and diameter, we had to split the data into multiple sections. So what you see here for the very first data file on the left, we did a raster scan to cover the entire 360 degrees circumference over a length of about 3 meters. So that was the limit for this first data file. And then we repeated the same thing a second, third, and fourth time, so that we end up having 4 individual data files that are about 3 meters long and cover the full circumference. So what I want to show you today is how to stitch those data together into a single report format. And just one interesting thing that we noticed while doing the inspection is that there was the presence of a dent indication. So probably just a rock that was pushing on the external surface of the pipe and created that deformation or that dent. So our procedure for inspecting a pipeline joint with the Spyne is in 3 steps. First of all, the first step was done just before the coffee break. So I have inspected it with the Spyne and my Ready. This is finished. Now, what I am doing is I took the data files from my Ready and send them over to my analyst, Noah Johnson, who is at the office and who will show you how to use SIMS Pro, the reporting software, to stitch the 4 data files that I get. It will stitch them together and produce a final report. And while he is doing that, I'll just be here and enjoy my mug of coffee with you guys.
I guess we're live, Mathieu. Thank you very much. Good job on the data files. So while we're doing that, I went ahead and opened the data files. So I've got them here. So let's see what we've got. Okay. So I can see that, Mathieu, you took a few photos of the inspection. Good job. That'll be handy for the report later on. And I see you have 4 data files. So Spyne 0, 1, 2, 3, and no, sorry, 1 to 4. Okay. So what do we have on our data here? Okay. So looking at our C-scan, this is the axial one. I see there are what seem to be a few indications. So axial indications. Here, the alarm threshold is already triggering, so it's showing us that there's already about 6 indications here. If we check the transverse C-scan, we see there's nothing here. It looks clean. This tells me that we probably have several axial cracks in this pipe. So I'm just going to go through all these cracks one by one, and I'm going to report them as cracks. I'll go to the Analysis tab, and I'll hit Next. That'll bring me to the first defect of the C-scan, and I'll just zoom in, and that will give me a nice screenshot of the indication once I report it. So there we go. This one seems to be a crack. We've got a nice, signal which looks just like a crack, so I'll report that as a crack. And now I'll just go through all of these one by one and check them and report them. So here, another crack, 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 crack. And there we go. We're done with this C-scan. I'm going to zoom out. And now I've done the C-scan. I'm just going to go ahead and export the C-scan, so it's in a format which can be easily ingested by SIMS Pro. So that's easy as hitting Export C-scans. Here, I'm going to add an offset of 275 millimeters. That's because, as you know, the Spyne, the ribbon of coils is a little bit offset from the girth weld. So we're going to add that offset in our C-scan. There we go, all done. Now we can move on to the second data file. And now we're just going to repeat this process for all 4 data files. Okay, now what do we have here? This looks a little bit better. We still have a few indications according to our alarm. So I'll just hit next, zoom in, and true proportions, crack, next, crack, and we're done. So I'll again export the C-scan. This time I'll set the x-axis offset to 3 meters, so 3,000 millimeters. That's because, as Mathieu said, we've got 4 scans covering the 12 meters of pipe. Each scan covers the entire circumference. In this case, we've got a 3-meter offset from the start of the scan to the girth weld. So next data file, number 3. It looks like very clean data, Mathieu. Good job. It looks like you are doing a good job keeping the probe in contact and getting good data. That's important. So here we've got another few indications. I'll just zoom in again. Definitely looks like a nice SEC colony. Let's report that. Crack. And again, if we just check in the transverse, we'll see they disappear. That's really an axial crack. Crack, crack. So right now I'm using shortcuts, right? So I can change to the next defect, previous defect. I can change files. I can even add shortcuts for indications. This can be really quick. We'll export again our C-scan. This time it'll be 6 meters because it's the third C-scan. And there's one last C-scan remaining. And we're good to go. Now, Mathieu mentioned we had a dent here, so I'm expecting to see some blue spots, where you can see there's a little bit extra lift off from where the coils were, a bit removed from the surface by the divot in the material. And there we go. So if we look at that, we can see the defect, or in the indication, we can see the signals go down. That matches liftoff. We check the transverse C-scan. It looks very similar, right? So that's normal because we'd expect both channels to see kind of similar liftoff when we go over a dent. So in this case, I could add the indication in Magnify, but I'll just leave that for SIMS Pro. So we'll do it later on and you can see how it's done. So I can report this as no defects and export my C-scan. It's the last one, so I'll just add 9 meters and we're done. So at this point, we've finished our work in Magnify. We're ready to move on to SIMS Pro, where we can stitch all 4 C-scans together and make one nice image. Okay. So moving on to SIMS Pro, I've already got my inspection set up because we've been doing other stuff. It's a long pipeline, several inspections. So I'll just open the project and I'll create a new component for this section we've done. So I'll click on our line 1, add component. It'll be a pipe section. And here it'll be called girth weld 16080. The nominal would be 1050. Standard schedule. It's carbon steel. And I'll just change the length to 12 meters, like Mathieu told me. Next, here we'll leave the standard axial datums. So, with the flow and top dead center for the circumferential and finish. And now we've created our canvas. I'll just click on the component, save and exit, and we're here. We've got our canvas. So this is basically the image on which we'll paste all these C-scans. So now we'll start by going to the data tab and we'll import the data from our C-scans. Remember, SIMS Pro, the background is MFL and making reporting tank floors. So we're going to use the Magnify ECA C-scan importer, and we're going to import the C-scans from Magnify. Hit open, and we'll import, and that'll start. While that's happening, we're just going to go back to Magnify. We're going to talk about a few other things that I didn't mention. So if we reopen, say, the file number 1, we're going to see that we actually didn't report all the yellow spots, right? And that's desirable in our case. According to our client's procedure and specifications, we are not to report indications which are below the threshold of, in this case, 1.25 volts. That will depend entirely on what the client is requesting. So in this case, these are just too small to be reported. So there we go. Now back to Sims Pro. We're still importing our scans, but it's almost done. Once they're all there, we'll start moving them and kind of overlaying them so they can match up properly. There we go. So we can see we've got our 4 C-scans, each about 3 meters by 3 meters, kind of square. The first one, we remember we added an offset when we exported it, so it's there at 275 millimeters. That's correct. We won't move that one, but we will move the other ones. Remember, we set the offset to 3 meters, 6, and 9 meters. It doesn't need to be perfect. We're just looking to get an approximate value. That way we can, after the fact, have an easier time aligning the data files. Before doing that, I'm going to start by going to the settings. I'm just going to change a few things regarding the rendering. We're going to change the overlay behavior, and we're going to remove the scan outlines. Now ready to go. I can just zoom in, and I'm just going to look for a feature that I can use to align the data files. So in this case, I think I'll use these 2 little dots here. I'll just grab the second C-scan and just move it over the first one. And you can see there's kind of like a ghost look where we can see both files at once. That's normal. What Sims Pro is doing is it's taking the maximum amplitude of the voltage and it's displaying it on the C-scan. So this way, there's no way you'll ever miss a defect by covering it up. So now we'll just align it with those features. That looks good. We can leave it there. We'll just move on to the third file and repeat the same process. You can see how the blue spot here disappears because it's lower. There we go. One last time. Here, I'll just use, these lines here. I'll line that up. That looks pretty good. Okay, very well. Now we can see we've got our indications, which were transferred over from Magnify. They're still there. That's good. However, we wanted to add some defects for the dents. So we're just going to go ahead and go to the Home tab, and we'll add an indication. It's easy as, hitting the button and just creating a square around that dent. And we'll do another one for the larger dent over here. You know what? And I'll just, while I'm out there, I'm going to say, Mathieu found a rock against the pipe. Okay, so we're just leaving a note so that we know what happened there. So now if we open our indication list, if we click on the component, we'll see all the indications. So there we go. We've got 12 indications as well as 14 indications, 12 cracks, and 2 which haven't been identified yet. If I click on an individual C-scan, I'll only see those indications. So over here on our dents, we're just going to report these as dents. Good. And now if we go back to the entire one, we can actually double click on the defects and we can zoom in and look at them. And if we want to, we could change the type here. We can also add a prove up value. And we can also add a method. So let's say you've got a Shark HR. You can go ahead and measure the real depth of those cracks, the Shark HR, add that value, and then it'll be in your report. Again, we can also add notes. So we'll see it down here. For this one here, we've got the note we wrote about the dent. So that looks good. Now, before creating our report, one last thing. You can also add, drawings. You can add shapes and various things on the component. So we can add rectangles, circles, lines, and also add a measurement or markers on the scan. If you're going to perform any repairs, like you're going to grind away those cracks, you can also add those repairs, and you'll have those list of repairs, which will be part of the report and the component. So at this point, I will just, before we're done, add a circumferential weld right here, where we started. We can't see the seam weld here, so I'll just leave it like that. And at this point, we're done with our stitching our data. So we're ready to move on to the report. Now, if we already had a template done, we could just load it. In this case, I'll create a report from a blank page just so you can see how easy it is. So we'll create a blank report. It starts with just, a white page. That's no problem. What we do now is we click on the component we want to report. So I'll just click on the canvas here. And I'll scroll down. you'll see we have all these reportables. These are just basically drag and drop items which you can put into your report and will autofill it for you. I'll start with a report cover, which we'll just drag and drop and it'll appear there. We will come back and edit it later. After that, I'll add a report summary where I can add some text about the inspection, add any notes about the overall inspection, and information like the inspector, who reported the report, and who approved it. Next, I'll add an indication list to the report. There we go. All those defects, all the indications we added are there automatically. No need to do any extra work. And next, I'll add a scan list. So all the 4 scans that we performed, along with, the device used, where the scan is, the version used, it could be the inspector, all those interesting information. Last but not least, we're going to add some component info. So what we were inspecting, pipe, the length, all those things, and we'll finish it up with a component image. So here, that looks good. I'll just go back through these pages and edit the fields a little bit so we can make it more appropriate. So we'll call this the pipeline inspection report. There we go. I'm going to go choose a different image though, because we've got better. Thankfully, Mathieu documented his work. So let's just go to the project. And you know what? I'll just, grab that image. It looks great. We can refresh and it'll autofill it for us. Next page, our summary. Here, I won't actually fill it out, but obviously in real life, when you're doing this in the field, you'll have to do this yourself. It'll take a little bit longer. Next page, indications list, we can leave that as is. It looks good. Scan lists here, if we want to, we can edit these fields. So we can say, what, the inspector isn't imported. We can either add it later on when we edit the Word file, or we can add the inspector or remove the inspector, and it'll look a little bit cleaner. Component info, we'll leave that as is. And last but not least, the component image. We can choose what view to display. So axial, vertical, horizontal, transverse, as we wish, which device. We'll leave it as is, but we'll change the zoom ratio, right? Because if you're inspecting a long pipe, it's interesting to kind of squish it so you can see it all on one page. We'll just change that to 1/2. And I'll just remove the scan outlines to make it look a little bit cleaner. And there we go. We're done with our report. At this point, we can save the report. If we want, we can save it as a template, and that way next time we can just reload the template and it'll just autofill this all for us, and we'll only need to, add the report summary basically. So I can save the report. Easy as that. I could export it as a Word file, and then I could go edit it if I want to do some more more in detail editing. In this case, I'll just create the PDF. I'll call it Griswold 16080 report. And at this point, we're basically done. We can go review the report. So pipeline inspection report, ECA with Spyne. We've got a nice picture of the pipeline. Good job, Mathieu. We've got our report summary, all of our indications. We've got the location of all these indications. And remember, these locations are actually adjusted based on when you stitch the CCNs together. So if there's any mistakes, it'll kind of correct for that. And there's our note we added, looking good. Our list of scans and our inspection. So we can see all of our little indications here, as well as a grid, so we can know where they are. That's pretty much it. Back to you, Mathieu.
Yeah, thanks a lot, Noah. That's very useful. And so you saw overall, it took me maybe an hour to an hour and 15 minutes in the beginning to actually scan the pipeline with the Spyne. Add to that 20 minutes for reporting in Magnify and SIMS Pro to call all the indications, and you end up being in and out of the dig within about just less than 2 hours, having done your inspection, reported everything, and given the client a PDF report. So it's just really, really helping to improve productivity, get faster inspections, faster reports, and just be overall have more valuable data also. So that's everything we wanted to present, just using Spyne as a replacement for magnetic particles and using SIMS Pro for reporting. So thank you very much. We will look now at the Q&A if there's any questions.
So can you add MPI pictures to your report? Yes, you can. In Sims Pro, you can add a marker, and you can add an attachment to your marker, so you can add pictures like that. And if you want, you can actually even report those in the report automatically. That was one of the reportables that I didn't use because I didn't add any pictures.
And just to add to that, same thing with proof of depth. If you do any phased array UT or shark or other techniques to measure the depth of the cracks, there's a field in Sims Pro to write down the depth that you measured.
Can you discard an indication in Sims Pro? Yes, in fact, if you want, you can select the type of defect within Sims Pro, and you can actually discard it too. Just make it red, and then within Sims Pro, you can only show the accepted indications, so those will, all the other ones will disappear. Is there a way to add all the indications at once instead of clicking on them one by one? Well, generally, we recommend you go one by one through all the defects so you can actually look at each one individually. But if you want, you can actually just report all the indications in a C-scan. And then what you could do is you could look at them later on and change them in Sims Pro.
Can you use it through paint? Yes, we can. So the spine can tolerate the lift off of about 3 millimeters. So as long as your paint or coating, epoxy coating, stuff like that is not over 3 millimeters, you can use it through and do all the detection through the paint. Okay, can we add geolocation for the component? Yes, there's editable fields in Sims Pro, so you can add that type of information. It's not something that you get directly from the data file, I think, Noah, but you can add it.
Well, you actually have all that information in your photos if you use geolocation on your photos.
Right.
So if you just add the photo there, the information will be there.
Is it possible to use on a spiral weld pipeline? Very good question. It is possible. It really depends. It's a case-by-case question. So it depends on the thickness of the weld, how wide it is, and how high it is. So you can do the spine over the weld, no problem. But sometimes you will lose a little bit of sensitivity at the weld toe, especially if the weld has a very large cap. But yeah, you can do spine over the weld.
Yeah, and you can even add that on the in Sims Pro. You can add the marks for the spiral welds, so you can actually see it in your report.
Yeah, that's true, and it really shows up as a spiral on the on the mapping. All right, I think that's all for today. Thank you very much for attending again, and if you have any more questions, our email addresses are there. Thank you.
Thank you very much. Bye.